Yes, dear students, so today we are going to start about the third semester class. As you know, so you have come for the first time in the third semester and taking the inorganic chemistry class. So as you all know, I am Dr. S.D. Dhumwad, Associate Professor of the Chemistry Department, and I want to tell about the syllabus what I am going to teach this particular year, I mean the semester. Now the semester, in this semester I am going to take chemistry of nonmetals. So in this chemistry of nonmetals, we have preparation, structure and properties of diborane and borazole, classification of silicates, preparation and structure of NF3, N2F2 and SOCl2 and S4N4, preparation properties and structure of ClF3, BrFi and IF7, structure and bonding in xenon compounds, XeF2, XeF4 and XeO3. So this particular syllabus carries the 6 hours. And another topic I'll be taking, that is solids. So in the solids you are going to learn about the space lattice, unit cell, calculation of particles per unit cell, laws of crystallography, symmetry elements in crystals, derivation of Bragg's equation, determination of the structure of sodium chloride by rotating crystal method, defects in stoichiometric crystals, Schottky and Frankel defects, and non-stoichiometric crystals, metal excess and metal deficiency crystals. Now this carries the 6 hours. Now before to start with this particular syllabus, let us we study about the bridge course, because this chemistry of nonmetals basically deals with the structure and bonding. In your previous second semester, you have studied about the chemical bonding. The question arises here, what is a chemical bond? So as you know, the bond is a sort of a force that keeps the two atoms together. I repeat, the bond is a sort of an attractive force between the two atoms which keeps the atoms together. Now in this, the bonding, we have ionic bond, covalent bond, coordinate bond, metallic bond, hydrogen bond and van der Waals force of attraction. Among these bonds, ionic bond, covalent bond, coordinate bond and metallic bonds are the stronger bonds, whereas the hydrogen bond and van der Waals force of attraction, these are the weaker bonds. Now in this, the ionic bond, as you know, you have studied in the previous semester, ionic bond is a sort of an electrostatic force of attraction between the two ions of opposite charge. So, and you know, it is a stronger bond and it is a non-directional bond. It is not having any direction. So therefore, ionic bond is compounds which contains this ionic bond, they are called ionic compounds. You have studied the properties of ionic compounds also. As you know, all ionic compounds are crystalline in nature. They are all soluble in water and so on. You have many more properties which you have studied. Coming to the another bond called the covalent bond. As you know, the covalent bond is formed between the two atoms by sharing unpaired electrons. And this covalent bond is having a direction between the two atoms. The compounds containing covalent bonds are called the covalent compounds. The covalent compounds may be either the solids, liquids, or the gases. And you have studied many more properties of the covalent compounds. We know to explain about this covalent bond, many theories have been proposed from time to time. So among them, the first is the Lewis theory. The second is the valence bond theory. This valence bond theory is further extended, called the hybridization. The next we have valence shell electron pair repulsion theory, and finally we have the molecular orbital theories. Now, to know about the Lewis theory, the Lewis proposed a covalent bond is formed between the two atoms by sharing unpaired electrons. And he said there are two types of covalent bonds. One is a non-polar covalent bond. Another one is the polar covalent bond. The example like hydrogen, fluorine, chlorine, nitrogen, oxygen are the examples of non-polar covalent bond, and HCl, water, ammonia, etc. are the examples of polar covalent bond. And in this Lewis theory, he also explained the formation of a covalent bond between the two atoms, and he also explained about the dipole moment present in polar covalent bonds. Of course, you have studied the so many aspects of the Lewis theory and their structures in the earlier semester. Next comes another theory called the valence bond theory. So according to this theory, a covalent bond is formed by overlapping of atomic orbitals. So we have SS overlapping, SP overlapping, and the PP overlapping. So the covalent bond formed by overlapping of S and S orbitals are called SS overlapping. Example is the hydrogen. So the covalent bond formed by overlapping of S and P orbitals is known as sp overlapping. Example is the HCl. Similarly, the covalent bond formed by overlapping of p and p orbitals is called the pp overlapping, and example is the HCl. The chlorine. The next, this covalent bond is explained by the Sidgwick and the Powell, and they explained the so many molecules like hydrogen, oxygen, nitrogen, chlorine, HCl, and so on. But this theory could not explain about the geometry of the molecules. So when a molecule is having more than two atoms, then to explain the geometry of the molecules, the valence bond theory could not explain about this. So therefore, this theory was extended by introducing an idea of hybridization. Hybridization is nothing but it is a process of mixing of atomic orbitals of slightly different energies to form the new orbitals of equivalent energy is called hybridization. The hybridized orbitals, they orient in space to give a definite geometry to the molecules. So in this hybridization, you have studied sp hybridization, sp2 hybridization, sp3 hybridization, sp3d hybridization, and sp3d2 hybridization with examples. And these hybridized orbitals, they have a perfect geometry, therefore they have zero dipole moment. Some of the molecules have a distorted geometry having some certain dipole moment. It is because of the presence of lone pairs of electrons. The examples of this type of molecules are ammonia and water molecule. Then The another theory called the VSEPR theory was also introduced, which you have studied, valence shell electron pair repulsion theory. In this valence shell electron pair repulsion theory, so the these valence shells, they have a lone pairs of electrons. These lone pairs of electrons, they share to form a molecules. Now here, between the two atoms, we have the repulsions like bond pair repulsion, bond pair repulsion, and lone pair repulsion. So you have studied lone pair repulsion is greater than lone pair repulsion, which is further greater than bond pair repulsion. Based on this theory, so the structures of the above molecules can be explained. Coming to the another aspect called the molecular orbital theory. This molecular orbital theory is formed by the overlapping of atomic orbitals in case of valence bond theory. But in case of molecular orbital theory, these atomic orbitals, they not only overlap, they combine to form the new orbitals called molecular orbitals. The molecular orbitals have molecular orbital is having lower energy and another molecular orbital is having higher energy. The one which is having lower energy is called bonding molecular orbital, and the another one which is having higher energy is called anti-bonding molecular orbitals. Bonding molecular orbitals are formed by the symmetric combination, and anti-bonding molecular orbitals are formed by the asymmetric combination. Symmetry leads to the lower energy and greater stability. Asymmetry leads to the higher energy and the non-stability of the bonding. In this regard, you have also studied the structures of various molecules. So you have studied the energy level diagram in case of bonding and anti-bonding molecular orbitals like hydrogen molecule, so helium molecule, Li2 lithium molecule, beryllium molecule, nitrogen, oxygen, fluorine, and so on. Then you have also studied the third category of a bond called the coordinate bond. The coordinate bond is formed by donation of an electron pair from one atom to another. So in this case, an atom which donates a lone pair of electron is called the donor, and the atom which accepts the lone pair is called acceptor. The donors, they donate a lone pair to acceptor, therefore a coordinate bond is shown by an arrow mark from donor towards the acceptor. Generally, the acceptors are the transition metal ions. So they act as the acceptors, and the molecules having lone pairs of electrons, they act as donors. And detailed studies of this coordinate bond you are going to study in 5th semester, a topic called coordination chemistry. Then you have also studied about the metallic bond. The metallic bond is formed between the two metal atoms, and this metallic bond is not a directional bond. This is also a non-directional bond, and it is not between only two atoms. It is the bond is among the atoms. So this also you have studied in the earlier class. You have also studied about the hydrogen bond. So the hydrogen bond is formed between when hydrogen atom lies between the two strong electronegative atoms like the NOF, nitrogen, oxygen, or fluorine. Now in this hydrogen bonding, so when hydrogen lies between the two strong electronegative atoms like nitrogen, oxygen and fluorine, so between hydrogen and NOF you have a one covalent bond and another a weak force of attraction, and that weak force of attraction is shown by a dotted line called the hydrogen bond. So the water is an example of a molecule containing hydrogen bond. Because of the hydrogen bond, the molecule is liquid in nature, which is essential for the living organisms. This in hydrogen bonding, we come across the two types of hydrogen bond. It's called the intermolecular hydrogen bond and intramolecular hydrogen bond. Intermolecular hydrogen bond means it is present between the two atoms, the two molecules, and intramolecular hydrogen bond is present in the molecule itself. Lastly, you have also studied the van der Waals force of attraction, which is a weaker force of attraction between the molecules in a closed system. So these are some of the basic points which you must know, because in the chemistry of nonmetals you are going to study the structures of various molecules. Now, having this the bridge course, now let us take the next slide, the chemistry of the p block elements. As you know, you have studied in the PUC class the chemistry of S block elements, P block elements, D block elements and F block elements. S block elements are the metals and P block elements include the metals, non-metals and metalloids, and the D block elements are also called the transition elements, and F block elements are also called the inner transition elements. Now today's the topic here, you are going to study first about some of the general characteristic features of the P block elements. So the elements where valence electrons enters into the p subshell are called the p block elements, and general electronic configuration is ns2 np from 1 to 6. So group number 13 to 18 are the p block elements. They include mainly non-metals but also have the metals and the metalloids. So the examples of the metals in a p block are aluminium, gallium, indium, thallium. The next, also you have tin, lead, bismuth and polonium. Metalloids of the p block elements are silicon, germanium, arsenic, antimony and tellurium. The boron, carbon, nitrogen, oxygen, fluorine and neon forms first period. Across the period, when you move, you know that when you move from left to right in a period of the periodic table, atomic and ionic size decreases, non-metallic character, ionization energy, electronegativity increases. When you go down the group, atomic and ionic size increases, metallic character also increases. This you have already studied in PUC levels. Now, the maximum oxidation state of the p block elements can be given as the group number -10. For example, the boron belongs to a group number 13. So the boron is having a valency or oxidation number 13 minus 10, that is 3. Similarly, if you take the sulfur, sulfur belongs to a group, the 18. So, the sulfur belongs to a group 16. So, in this, if you subtract 10, so it is having 6. That means maximum valency of sulfur is 6. Now, if you take the p block elements, generally they show covalency. That means they have a property of the sharing the electrons. Covalency means sharing the electrons. Higher members can show electrovalency, and some of the elements show coordinate valency also. That means majority of the p block elements form a covalent bond. Some of the p block elements, they form ionic bond and also the coordinate bond. When we move from left to right in a period, reducing nature decreases and oxidizing nature increases. Therefore, halogens are strong oxidizing agents. And also you have studied the another, most of them forms acidic oxides. Yes, non-metallic oxides are acidic oxides, metallic oxides are basic oxides. Example, potassium oxide is a basic oxide, calcium oxide is a basic oxide, because when these are dissolved in water, they forms the respective hydroxides. Whereas the non-metallic oxides like carbon dioxide, sulfur dioxide, phosphorus pentoxide, when they dissolve in water, they form carbonic acid, the sulfuric acid, phosphoric acid, and so on. So therefore, these are called acidic oxides. Compounds of p block or elements, they do not impart characteristic color to the flame. You know, the S block elements like lithium, sodium, potassium, rubidium and cesium, they exhibit some characteristic color to the flame. Even though like this, even the metals of non-metals or the non-metals of the p block elements or the non-metals of solid state, they do not exhibit any color to the flame because they are all covalently bonded compounds. Chemical properties of p block elements differ from one group to another. Many p block elements exhibit allotropy. So the examples of the elements which shows allotropy are carbon, silicon, phosphorus, sulfur and so on. They also exhibit another property called the catenation. That means the chain forming. Catenation means the chain forming the elements. They forms a chain. Example, carbon, silicon, germanium and so on. They also exhibit inner pair effect, that is tendency of being less availability for ns electron in bonding. This increases down the group. They really forms anions. Due to small size, high electronegativity and high ionization enthalpy, the first elements of each group differs from rest of the members of the respective groups. This is another property of the p block elements. So you have, since all these things you have studied, just I have rebrushed these aspects. So before to go with the other aspects. Next, we take a particular thing, that is the boranes. So you have to study what are boranes and how these boranes are prepared and what is the structure of the boranes, what are the other properties of the boranes, what are the types of boranes. These aspects let us we study in the next class. Thank you.